Hi everyone, welcome to my YouTube channel. Those who are not subscribed, please subscribe my channel. Those who have already subscribed, please watch my videos, share my videos and like my videos. And don't forget to press the bell icon to get the next video notification. So regarding trends of periodic table, already we have studied about the first one is valence electron, second one is valency, third one is about atomic size, and the last of the syllabus trends of periodic table is metallic and non-metallic property. So metallic property, or it is also called as electropositivity. So in the examination they may ask explain the metallic property, how it varies across the period and down the group, or they may ask how the electropositivity vary across the period and down the group. Both the questions are one and the same. So now let us explain what is metallic property or electropositivity. So electropositivity is the ability of an element, it is the ability of an element to lose electron. ಯಾವ ಎಲಿಮೆಂಟ್ಗೆ ಎಲೆಕ್ಟ್ರಾನ್ಗಳನ್ನು ಕಳ್ಕೊಳ್ಳುವಂತಹ ಎಬಿಲಿಟಿ ಇರುತ್ತೋ ಅವ್ರನ್ನ ಎಲೆಕ್ಟ್ರೋಪಾಸಿಟಿವ್ ಅಂತ ಕರಿತೀವಿ. ಆಲ್ ಮೆಟಲ್ಸ್ ಆರ್ ಎಲೆಕ್ಟ್ರೋಪಾಸಿಟಿವ್. All metals are electropositive. What is the meaning of all metals are electropositive? All metals are electropositive means all the metals have the ability to lose electron. So therefore all metals are called electropositive. Electropositivity is the ability of an element to lose electron. Now let us study about how the electropositivity vary across the period and how it vary down the group. So let us see the third group elements. The elements that belongs to third period. The elements that belongs to third period are sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine and argon. As we move across the period, now we observe all these three, sodium, magnesium and aluminium are metals. Silicon and phosphorus are metalloids, that is they are semiconductors, and sulfur, chlorine and argon are non-metals. They are non-metals. Then what can we give the conclusion? As we move across the period, the metallic property decreases because first metal irutte. ಈಗ ನಾವು as we move across the period metal ಇದ್ದಿದ್ದು ನೆಕ್ಸ್ಟ್ ಮೆಟಲಾಯ್ಡ್ ಬಂತು, ಆಮೇಲೆ ನಾನ್ ಮೆಟಲ್ಸ್ ಬಂತು. ಅಂದರೆ ಅರ್ಥ ಏನು? ಮೆಟಾಲಿಕ್ ಪ್ರಾಪರ್ಟಿ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಆಸ್ ವಿ ಮೂವ್ ಅಕ್ರಾಸ್ ದ ಪೀರಿಯಡ್ metallic property decreases. Why the metallic property decreases? The metallic property decreases because the nuclear charge increases. The nuclear charge increases. As the nuclear charge increases, the electrons are pulled. The electrons are pulled. The electrons are pulled towards nucleus. Electrons are pulled towards nucleus. So no electrons are set free. ಯಾವುದೇ ಎಲೆಕ್ಟ್ರಾನ್ಗಳು ಫ್ರೀ ಆಗಿರೋದಿಲ್ಲ. If the electrons are not free, then there is no movement of electrons. If there is no movement of electrons, then the element behaves like a non-metal. ಯಾಕೆಂದರೆ non-metal is a poor conductor of electricity. So ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ಗಳ ಮೂಮೆಂಟೇ ಇಲ್ಲ ಅಂದರೆ there is no flow of current and hence they behaves like a non-metal. So this is the reason we have to write. So as we move across the period, metallic property or electropositivity decreases. For example, as we move from sodium to argon, the metallic property decreases. As we move across the period, ಸ್ಟಾರ್ಟಿಂಗು ಮೆಟಲ್ ಇತ್ತು, ನಂತರ ಮೆಟಾಲಾಯ್ಡ್ಗಳು, ನಂತರ ನಾನ್ ಮೆಟಲ್ಗಳು ಬಂದವು. ಹಾಗಾದರೆ as we move across the period, nuclear charge increases. As the nuclear charge increases, the electrons are pulled towards the nucleus, so no electrons are set free and hence they behave like a non-metals. That means as we move across the period, metallic property decreases. Then coming to what happens to the metallic property as we move down the group. So for example, I have taken here, so 14th group elements, that is carbon, silicon, germanium, then tin, lead. So if I take this one, notice carbon is a metal, carbon is a non-metal, then silicon and germanium are metalloids, then lead and tin both are metals. So tin and lead both are metals. Agar enaito, as we move down the group, so as we move down the group, metallic property increases. So as we move across the period, metallic property decreases. As we move down the group, metallic property increases. As we move down the group, what is the reason? Because the number of shells, as we move down the group, the number of shells increases. As we move down the group, the number of shells increases. So distance between nucleus and valence electrons increases. So electrons are set free. Since the electrons are set free, the electrons can move. Since the electron can move, then we can call that as a metal, because in a metal the electron can move freely. Since there is a flow of electron, then metal behaves like a good conductor of electricity. So this is the reason we have to write here. What is the reason? Because the number of shells increases as we move down the group. As the number of shells increases, distance between nucleus and valence electron increases. So electrons are set free. Valence electrons are set free, and hence there is a movement of electron. Since there is a movement of electron, then the element behaves like a metal. Therefore, metallic property increases as we move down the group. This is about metallic property. Now let us study about non-metallic property or electronegativity. So what is meant by non-metallic property, or it is also called as electronegativity? The ability of an element to gain electrons. The ability of an element to gain electrons, they are called as electronegativity, or it is called non-metallic property. All non-metals are electronegative. That means all the non-metals have the tendency or the ability to receive electrons, therefore, or to gain or receive the electrons. So they are called as electronegative. Now let us study what happens to the non-metallic property as we move across the period. So as we move across the period, these three are metals. This is the third period. These two are metalloids, and these three are non-metals. So by seeing this one, we can tell that as we move across the period, non-metallic property increases. So why the non-metallic property increases? Because the nuclear charge increases. As the nuclear charge increases, no electrons are set free. That means the electrons are pulled towards the nucleus and no electrons are set free. If no electrons are free, then there is no movement of electrons. Since there is no movement of electrons, there will be no conduction of electricity. Therefore, they behave like a non-metals. So this is what we have to write regarding non-metallic property as we move across the period. Compulsory what we have to do is, you have to keep one example. So example shows everything. Then as we move down the group, what happens to the non-metallic property? So this is carbon is a non-metal. Then both silicon and germanium, this is 14th group element. Silicon and germanium both are metalloids. Then tin and lead are metals. So as we move down the group, the metallic property decreases. The metallic property decreases as we move down the group. So ಹಾಗಾದ್ರೆ ಇದನ್ನ ನಾವು ತಿಳ್ಕೋಬೇಕಾಗಿರೋದೇನು, as we move down the group the non-metallic property decreases because the number of shells increases. The number of shells increases. So distance between nucleus and valence electron increases. So electrons are set free. Since the electrons are set free, they behave like a metal. Therefore, as we move down the group, non-metallic property decreases. So as we move across the period, non-metallic property increases. As we move down the group, non-metallic property decreases. So across the period increases, down the group decreases. So this is about non-metallic property. Now let us give conclusion for all the 10 trends of periodic table: valency, valence electron, atomic size, metallic property, non-metallic property. Let us give conclusion for all the 5. So now let us give the conclusion for all the 5 trends of periodic table. One is valence electron. As we move across the period, so valence electrons increases from 1 to 8. That means valence electron increases. Then as we move down the group, valence electron remains same. This is the first one. Then coming to the valency. So as we move across the period, the valency increases from 1 to 4 and decreases from 4 to 0. That means valency across the period first increases from 1 to 4 and decreases from 4 to 0. Then what about the valency down the group? Valency down the group remains same for all elements of that group. ಆ ಒಂದು ಗ್ರೂಪಿಗೆ ಬರುವಂತಹ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಳ ವೇಲೆನ್ಸಿ ಒಂದೇ ಆಗಿರುತ್ತೆ. ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಳ ವೇಲೆನ್ಸಿ ಒಂದೇ. ಸೆಕೆಂಡ್ ಗ್ರೂಪ್ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಳ ವೇಲೆನ್ಸಿ ಒಂದೇ. ಫಸ್ಟ್ ಗ್ರೂಪಿಗೆ ಬರುವಂಥ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಳ ವೇಲೆನ್ಸಿ 1. ಸೆಕೆಂಡ್ ಗ್ರೂಪಿಗೆ ಬರುವಂಥ ಎಲ್ಲ ಎಲಿಮೆಂಟ್ಸ್ಗಳ ವೇಲೆನ್ಸಿ 2. ಸೊ ವೇಲೆನ್ಸಿ ರಿಮೈನ್ಸ್ ಸೇಮ್ ಫಾರ್ ಆಲ್ ದ ಎಲಿಮೆಂಟ್ಸ್ ದಟ್ ಬಿಲಾಂಗ್ಸ್ ಟು ದಟ್ ಗ್ರೂಪ್. ಇನ್ನು ಅಟಾಮಿಕ್ ಸೈಜಿಗೆ ಬರೋಣ. Atomic size, as we move across the period, atomic size decreases. ಆಗ್ತಾ ಹೋಗುತ್ತೆ. As we move down the group, atomic size increases. Then coming to the metallic property, as we move across the period, metallic property decreases. As we move down the group, metallic property increases. Then coming to the non-metallic property, as we move across the period, non-metallic property increases. Then as we move down the group, non-metallic property decreases. So these are the things that you have to keep it in mind. So thank you for watching my YouTube channel. So those who are not subscribed, please subscribe my channel. So thank you very much.